Alright guys, this is Timothy here again. Um so this is the continuation of concurrency. In the last video I talked about the theoretical parts of concurrency, what concurrency is, and I also showed you some of the how Go actually makes concurrent programming possible. So in this video we are going to dive into the meats of the matter and actually use Go routines and channels to write some really basic programs. All right, so let's get started. So the first thing we're going to do is we're going to create a function. Okay, so this is what we call an anonymous function. It does not have a name, and this function is going to print to the console. So just going to say hello Goroutines. All right, that's all. Now this is a function. Remember that in Go, functions are first class objects or something like that. So what that basically means is that functions are can be created like variables and assigned to variables. So we can actually have something like this. Sorry. So this is actually a valid Go code, and yeah, declare but not used. So which means this is valid. All right, but that's not what we want to do here. So we have this function, and we want this function to be executed once we run this code. So to do that, we call the function. So how do you call this function? You can put this, or actually let me do it like this so it's clear to you before I remove that. So we're going to declare a function variable called f. So we can come here and call that function. All right, so let's run this code. As you can see, prints this hello world, sorry, hello Go routines here. Okay, so we can actually get rid of this and just call the function directly. So we can do like this, and this should give us the same result. Yeah, so let's create a second function, and it's anonymous, so we don't have to name it. All right, actually I'm going to remove this hello here, and so it's like this, hello Go routines. All right, so let's run this. It works well, fantastic. So now this is not a Go routine, okay, and these are just function calls, very real function calls, and when the execution starts, these functions will actually block the main Go routine. All right, so I forgot to mention that the main function is actually run by a Go routine. It's actually a Go routine that starts up the main thread or the main Go routine. Okay, so this is the main Go routine. This is the main one, and once this main Go routine exits, all of the program stops. Nothing else could run again. Okay, so now let's tell Go to run these functions, this first function in a Go routine. Let's start with the first one. Okay, so this is how to do that. Now let me run this. Oops, what just happened? The hello is no longer printing. Okay, let's try the same with the second one and see what happens. And nothing is printing to the console. Why is that? So when the execution gets to this particular snippet of code, the Go will create a separate green thread, a separate thread that is a separate Go routine. All right, and this function will be executed inside of that Go routine. So this does not wait. It doesn't block the program. It doesn't wait for this Go routine to finish. It just sends it off and continues. All right, notice the first time this happened that this one executed successfully. That is because it was blocked down here. Okay, so how could we fix this to make our print statements to actually work? We could tell the main Go routine to wait, just wait for maybe 1 second. That should be enough. So to do that, you can use the time package to create a time. So it's time dot pass duration. Just want a duration, which you can just say 1 second. Okay, so and then you can now tell the main Goroutine to sleep for 1 second. That's basically what we are doing here. So that should give these two time to complete. So if we run this, yeah, it works. So as you can see, there was a delay, which means it was waiting for 1 second to actually complete before exiting. So that was what gave these two Goroutines time to actually complete their tasks. Yeah, so this is the first mind boggling thing about concurrency, but hold on, we're going to do some more some more exercises, and hopefully you get the hang of it. All right, so let's say that we want to print this, so we want to use a loop to actually print this. So I'm just going to use a for loop. So just use for of loop, or oh no, let me use this. So faster typing, and we'll just say 5 times, right? So we want you to print hello 5 times, and each time before you do that, we want you to wait for 100 milliseconds. Okay, so I'm just go ahead and say time dot pass duration, say 100 ms. I don't think this will work because it's not gonna work. So I'm just going to create this in a different Goroutine duration. Okay, I'm going to pause this video and finish typing this out. All right, so I'm back. So what I did was to create a time type that is just 10 milliseconds. Okay, so what is happening in Goroutines is we wrote a for loop that would print hello 5 times, and after each print statement, the Goroutine should go to sleep for just 10 milliseconds. Okay, so the same thing happens down here, and yeah, and down here we're asking the main thread to wait for 1 second. Okay, so let's run this code, see how it goes. Okay, now let's try running this again. Notice how the executions went, right? Let's try running it again, and wow, something is not right. Do you notice something? So this is where what we call in a disorganized way comes into play. As you can see, the Goroutines are sort of swapping context of execution, so they're just swapping, because they are probably probably sharing the console resources, and there are some things that are beyond the control of Go itself. One of them is the operating system processes themselves. All right, so and every operating system manages dozens and if not hundreds of thousands of threads, and these things require the attention of the computer. As I'm touching my mouse right now, the operating system is supposed to respond to every move. If I type on my keyboard and touch my mouse at the same time, it is literally supposed to respond to these things, all right, and has to be aware of when to hold on, when to do some other thing. So it's a lot. So my point is that there are like very tiny nanosecond waits where the operating system switches to a different thing that as humans we don't really feel it because it's just way too fast. So because of these nitty-gritties, it makes concurrency a bit, it doesn't make it a bit, it makes it really, really disorganized, so that we can't really determine what's happening. And given the fact that this computer is I think it's 4 cores, I think it's 4 cores, so it means we have 4 different computers that are probably taking turns to run these processes. So this is how disorganized output was introduced into this code. Okay, so if I want to maybe have a bit deterministic response, I can use a runtime package. So in the runtime package, we have um, what we call Go max procs. So what this means, it tells Go the number of CPUs to use. As you can see, set the maximum number of CPUs that can be executing simultaneously. All right. So let's say use one. All right. So if I say use one, and I'm going to clear my screen. If I run this, and see, so if I try running this again, as you can see, there is a little bit of okay. Wow, actually the last time I tried this, there was a little bit of, it sort of reduced the non-deterministic way of doing this, but I think when I did it, I was actually using only one go routine, so maybe that is totally wrong. As you can see, there is still a lot of non-deterministic things happening here, and trust me, you cannot trust any of these things to actually happen the same. Yeah, it looks like we are having a go routines and the first three hellos coming out at the same time. Yeah, I guess maybe somehow there's a tiny bit of determinism introduced to our program now that we are using a single process. And if I continue repeating this, it seems like, oh, it seems like we have a deterministic well, yeah, so as you can see, the first time around this, we didn't really get a deterministic like a organized way of returning our result, but it seems like everything is just working that way right now. Yeah, but yeah, so this is what using one CPU does. It sort of reduces all of the context switches, and maybe the CPU can just focus on the same thing and doesn't get the confusion of having to respond to a lot of go routines at the same time. Okay, so we can increase the number of CPUs to use to 4. So if I try running this now, first time, if I try again, continue trying, and continue trying. Okay, let me change this down to 2. Right, sorry about that. Let me change this down to 2. Okay, yeah, exactly. I think my core is actually 2 cores. I don't have up to 4 cores. So yeah, as you can see, there a lot of non-determinism has been introduced right now. So you can see what's happening. So yeah, that is the basic definition of concurrency and using go routines. And so I'm going to stop this video here, and from the next video we're going to continue with channels, and we'll see how channels and how go routines can talk to each other through channels. See you then.